All right, I'm going to share my screen and we're going to go ahead and get started. Can everybody see my screen?
Yes, sir.
All right, cool. Well, everybody, appreciate you taking your time out today to join us for part 2 of our cannabis facility design tips and sustainability webinar. For those who have heard this spiel before, last week, I apologize. Essentially, I wanted to put together webinars, free webinars, to make the lives of those in the cannabis industry a lot easier. You know, I'm always pushing sustainability in all of our projects, but yet, you know, we're designing, doing MEP engineering for these facilities that consume quite a bit of power. So I feel like it's on my shoulders to at least try to do something to help with that, right? Because this planet is not getting any better. Um, just a quick background on Winston Engineering. We provide HVAC, electrical, and plumbing engineering construction permit plans for cannabis facilities, and that's for cultivation, extraction, manufacturing, distribution, retail. If it's in a building, we provide those types of plans. Um, we also provide alternative energy such as solar and battery backup. We also do generator design. We just got into fire alarm design. Now, I'll make this quick because you guys didn't come to see me talk. So, um, folks that are going to be speaking, we have Mr. John Zimmerman from Harvest Integrated, uh, Mr. Jesse Horton from Loud, and Chris Eggers from CC Security Solutions. So I will turn it over to John so he can discuss HVAC options that's hopefully going to save you energy and some money. So Chris, I will stop sharing and you can go ahead.
All right, thanks a lot, Anthony. Appreciate the opportunity to do this. Just admittedly up front, I'm going to let you know I'm a talker, so I'm trying to condense a lot into about 15 minutes. Maybe a little bit surface level. I'm not sure about the kind of the level of knowledge of everybody on, but nonetheless, we'll jump right into it. So, really discussing HVAC system options to save energy. You can really kind of look at that a few different ways. You can look at actual different systems and the options between those, or the options within each system, both of which with the eye towards efficiency. So I kind of hit both of those avenues. We're not going to go through every system type, again, because of the time, but going to look at the two systems, really kind of the generic systems that you see in cannabis the most frequently, which really are chilled water and direct expansion, or DX. So we'll run through that. Then we'll dig into some of the components and how they have an impact on efficiency, because regardless of the system that you buy, whether it's chilled water or whether it's DX, you're going to have many of the same components, and that's where most of the efficiency opportunities really lie. So I'll give you some ideas on what to look for when selecting that equipment. Then we'll go a little bit deeper and look at what's called in the HVAC industry, economization. Kind of the easy way to think of it is free cooling. So we'll dig into that and some strategies for doing that. My company, Harvest Integrated, our product Harvest Air really relies on the free cooling aspect heavily. And then at the end, we'll take a look at more of an ancillary system to the equipment, which is the air distribution, because there is a pretty good impact on efficiency with that. So first, let's take a look at chilled water, right? So just some real basic knowledge on how it works, how the chilled water system works. Effectively, you have two types of chilled water. You have air-cooled chilled water and you have water-cooled chilled water. What we're looking at here is air-cooled chilled water. All right, so here's your chiller. Your chiller is going to have compressors inside of it. Those compressors are going to have refrigerant in the compressor that's going to be used to exchange heat with the water that's eventually distributed to the building. So the waters get sent from that that piece of equipment to the building, out to each of the air handling units to provide cold water that will absorb the heat out of those rooms and then return that water back warm to the chiller. The air-cooled part of this happens when you get the warm water back from the building and you run it through these fans and you blow air across that water, or across the pipes with the water in it, to effectively reject the heat out to the atmosphere. So the key distinguishing feature for this particular method of chill water is that the refrigerant is air-cooled using the ambient air. So just by thinking of that, if you're in a place like I am in Dallas, Texas, where it could be 100 degrees on any given day, you're probably not going to get very good efficiency out of your air-cooled chill water. In the cooler climates, you definitely will. What you do get out of air-cooled chill water is a compact and integrated piece of equipment, which also makes it less expensive. But that's more on the CapEx side. We're looking here on the OpEx and the energy. So water-cooled chill water is the more efficient of the chill waters. Okay. And the way that you can determine water-cooled chill water is that there is a cooling tower on the project, right? So you have your chiller here and in this image here in the basement. And effectively you have two loops of water going from that chiller to one going from that chiller to the building, effectively distributing cold water, bringing it back warm. And then you have another loop of water that's going from the chiller to the cooling tower. And what's happening is you are transferring the heat from the building to the pipes that go out to the cooling tower to reject that heat to the atmosphere. And the refrigerant is water cooled. That's the real distinguishing feature here. So as opposed to air cooled chill water where you're blowing ambient air across it, you're using the real efficient heat transfer properties of water to cool the refrigerant down here. So water cooled chill water you can identify with the cooling towers on the project. Air cooled chill water, no cooling towers. Effectively the cooling tower is built into the unit, or the condenser, if you will. And the water cooled chill water is going to be quite a bit more efficient than air cooled chill water. And so yeah, look for the cooling tower in that respect. And then the third system we're looking at is direct expansion, or DX. So think about your house. I mean, that's a DX system. You have a condenser outside, you have your air handler inside, right? You have a coil inside, that's your evaporator coil, and then you have your condensing coil outside. So your compressors here will pump the refrigerant into the air handler. That refrigerant is going to be really cold. It's going to absorb the heat out of the air from the space and then pump that refrigerant back out to the condenser so that it can again be air cooled by the ambient air, right? So in this case, the refrigerant is the heat transfer fluid, the process fluid, as opposed to chill water. Also in this case, the refrigerant is used for, is air cooled using ambient air. So the condenser is used for the heat rejection. So similar to the cooling tower in that respect. So between these three different, well, really two systems, three different variations, if you will, the key takeaways in terms of efficiency when you're looking at making selections are this. If you're looking for efficiency, generally speaking, this is high level, right? We're not digging down into the weeds because there's all different avenues we could go down with that. When you're at full load, that means when you are at 100% of the load that you designed that equipment for, and no enhancements, we'll get into the enhancements here later. That's more or less just improving the components efficiency. Just generally speaking, you're going to be looking at water-cooled chill water being the most efficient out of these. Direct expansion, in many cases, will be the second, and air-cooled chill water, in many cases, will be the last. Now, one thing to note here is that chill water systems are going to lose their efficiency as you shed load. So for example, if just throwing some numbers out there, if you design the facility or the room for 1,000 plants to be in the room, and you only have, let's say, 500 plants in that room, that chill water still needs to keep operating and that water still needs to flow through the system. Right, so you're still going to be burning that energy, but you're going to be getting less use out of it, if you will. So in a situation where you're partially loaded, you're looking at direct expansion, really kind of getting close to similar efficiencies as water-cooled chill water. And then again, air-cooled chill water just kind of pulls up the caboose in this situation as well. So we'll dig into the components and take a look at those enhancements we were talking about here next. So the first component, which really, I debated whether even including this, but I got to say, in this industry, the biggest mistakes I've seen on HVAC and the biggest problems I've seen have come from a coil that was not properly sized for the application. So before we dig into why it wasn't properly sized, just some basics. There's really two types of heat. There's latent heat, so think about your humidity. That's your moisture in the air. And then there's sensible heat. So think about your dry heat. You always hear about Arizona being a dry heat and how it's more comfortable, right? That's because there's very little humidity in that air. It's a lot easier to cool that air than it is to cool very latent air. There's a term in engineering and HVAC design called the sensible heat ratio. All that is the ratio of dry heat to total heat, okay? So if you're in your house or if you're in an office building, the sensible heat ratio on that on the air going to that's being served by the equipment is going to be about a 0.8 or a 0.9. So effectively 80 to 90% of the air in the space that equipment is serving is going to be dry heat. If you're looking more in one of these facilities or more in a dehumidification application, so again, one of the flower room, if you will, you're going to be looking at that sensible heat ratio to be about a 0.5 to upwards of about a 0.65. So 50 to 65% of that air that the equipment is serving is going to be dry. That's a significant difference. And where you will find that difference is in the size and depth of the coil, the design of the coil. So when you are looking at coils, if you really want to get into it, take a look for the number of rows of coil. Right? You generally are going to see probably a 6-row coil in these applications, if not higher. In some cases, you may see a 4-row coil. But ultimately, what you're looking for is more surface area. If you have a high latent application, like a flower room, you need more surface area for that air to pass through so that there is time for that air to wring out the moisture from the air. So if you're looking at some design drawings and you want to know if your design is appropriate, essentially, a real easy way to look is to look on the equipment schedule. So that's the portion of your drawings. They're going to tell you what equipment goes where. And more than likely, you'll see this right here, sensible MBH, and you'll see a total MBH. Divide the sensible by the total and see where your sensible heat ratio is. If you're at a 0.8, you might want to ask the question. If you're at a 0.5, you're probably all right. So yeah, if the coil's not sized for the correct sensible heat ratio, your efficiency is going to suffer. Again, if you don't have enough depth and surface area on that coil to wring that moisture out, your unit's never going to stop. It's going to continue to operate until it reaches the set point. And if your coil's not sized right, it won't reach the set point. So you'll be burning energy and you will never get to the set point you want. So one thing that we always say is that not all tons are the same. Probably the best way to describe this is if you have a 10-ton unit that is designed to serve a comfort cooling application, you may have a 2 or 4-row coil. If you have a 10-ton unit designed to serve a flower room, you're probably going to have a 6 or an 8-row coil, something in that ballpark, right? So just hearing tonnage and knowing that you have the quote unquote total tonnage covered does not mean that you have an appropriately designed system for the application. And just a little bonus info here, when you reduce airflow and effectively reduce the velocity of that air, you will get more dehumidification capacity. So something to look for in your designs is you really kind of want to be in that 200 CFM per ton or 300 CFM per ton range. And just as a side note, generally speaking, for residential or comfort cooling applications, you're really going to be more towards a 400 CFM per ton. Again, none of this is meant to be highly technical. It's really just kind of rules of thumb to consider. So the next component's probably the most important in terms of efficiency is going to be your compressors. The compressors perform 80% of the work in the DX and in the chill water system. Okay, the compressor is what pushes the refrigerant. The refrigerant is ultimately what transfers the heat. So if you're looking to reduce energy usage, improve your efficiency, your compressor is going to be the lowest hanging fruit on what I call the energy efficiency tree. So how do we get more efficient with that, right? So we're really looking for turn down capability is what we're talking about here. There are various levels of turn down in terms of compressor designs. Let's start with no turn down, which is a single stage compressor. Probably representative of 90% of residential units that are out on the market right now. That means that compressor is either off or it's 100% on. There is no in between. Okay, so many of the kind of heartburn stories I've heard in this industry are that they, clients can't control the space. They're all over the place on their temperature and humidity. Then we'll find out that they've got a single stage compressor. So as soon as that compressor turns on, you're at 100% of that capacity. You may only be 50% loaded in the space. So that compressor is going to turn on, turn off really quick, right? So then you have a two-stage compressor, which just adds one level of turn down from that single stage. So call it 50%. Where you really want to be in this industry is you at least want to have some level of a digital compressor or variable speed compressors, right? And so digital compressors will stage usually somewhere about 4 to 5 levels to get the full capacity. Variable speed compressors, I don't want to say infinite modulation, but you can effectively dial that into exactly where you want it. And your control systems can ramp these things up and down so that you can effectively match load with capacity. That's the goal, is matching your load with capacity. If you have too much capacity for the load, you're going to be burning energy and you're going to lose control. If you don't have enough capacity for the load, you're just never going to turn the equipment off and you're going to keep running it, right? So it's really a matter of dialing that in and getting the right design up front with that. Examples of where this comes into play. So lights on to lights off. Once you shed those lights, you're effectively killing about 50% of the load in the space. If you don't have the ability to turn down your refrigeration, your cooling, or your heat rejection, you're going to overcool and overdrive the space, have trouble maintaining the conditions you want. Another situation is you're going to design these units for the most mature, the worst case scenario, right? So that's going to be your most mature plant with the most amount of irrigation and the highest level of lights. So in the early weeks of flower, that's not when you're going to see that, right? So it's nice to have some turn down capability there. And then again, on partially loaded rooms for whatever the reason, right? If you're only at 50% in the space or 75% in the space, again, that unit's going to be designed for 100%. So the ability to turn down is a very easy way to improve your efficiency on any project, really. And then the ancillary benefits of turning down is it's going to increase the lifespan of that compressor. Again, if you've got 50% of the load in the space and you've got a single stage compressor, so it means you're operating at 100%, that compressor is going to burn up a lot quicker than it's going to be if it's matching it precisely. And then again, like I've mentioned a few times, better control of your climate. So fans, they really kind of make up, I say the other 20%, but the majority of the remaining energy hit that you get from your equipment. And just like in compressors, you want to have the ability to turn down or have variable speed fans, right? Now, in many situations in this industry, you're going to have constant airflow in your space. So you're not necessarily going to be varying the airflow every minute in your space. But again, if you happen to be at 50% capacity, you don't need 100% of the airflow necessarily. So having that ability to ramp it down is going to be important in terms of efficiency. So what do we look for when we're looking for these types of fans? There's really two things you're looking for. There's what's called an EC motor or an EC driven fan. EC stands for electrically commutated motor. What you're looking at over here is an EC fan. The big difference you're going to see between this fan and what you would probably call a normal fan or an AC fan is the drive. It's going to be this motor right here. You'll notice you don't see that motor over here. You see a bunch of cables coming out of there. Those cables are essentially programming that fan to maintain a certain static pressure or a certain airflow, and it's going to ramp up and down as the conditions change in the space to match what you programmed it for. So EC motors or EC fans, and then AC fans, or just looking for a VFD, what's called a variable frequency drive. Effectively what that is it's a piece of equipment that will cut the electrical signal to the fan itself to vary the speed of the fan, and you can adjust that by adjusting the hertz of the signal. So both EC motors and VFDs allow for continual modulation. They both are very good options, and really the only reason you'd use one over the other is some different constraints, whether it's space or whatever it may be, but you can effectively achieve the same result with both. So again, adjusting airflow to match the load will improve your efficiency. And then just like with the compressors, the ancillary benefits really are better control of your climate. And in this case with airflow, because airflow has such an impact on plant transpiration and obviously the things downstream of transpiration, You can have more influence on the plant transpiration if that's something that you desire. All right, so going a little bit deeper, this is looking at economization or free cooling, okay? So economization is cooling without using the compressors. Remember, the compressors use 80% of the energy in your system, right? So free cooling. There's various types of economization. There's what's called direct economization. So that effectively is using the outside air and bringing it into the space as if you're opening the window to cool and dehumidify, right? So you don't have any losses of your heat transfer when doing that because you're not running it through a heat exchanger. But you are bringing in outside air and all that comes with it, all the pests, pathogens, temp swings, humidity swings, you know, the craziness with your climate, not exactly what you're looking for in the space. So then there's what's called indirect economization. That's when you're able to use the air, the outside air to cool and dehumidify without bringing the outside air into the space. And you do that via a heat exchanger. So what you're looking at here, this is a harvest air unit. This is the product that we sell. You see this wheel here, that's called a rotary heat exchanger. And in our case, that's specifically what's called an enthalpy wheel. That wheel is designed to absorb heat and humidity and transfer it, right? And it operates on a differential between this airstream and that airstream. So just from a high level, you got warm, humid air coming back from the space. We run it through that enthalpy wheel. Okay, that wheel absorbs the heat and humidity out of that wheel, or out of that air, and then we send that air back cool and dry to the space. So in a completely separate plenum, here's your separation right here. You're going to bring cooler, drier outside air in, run it through that wheel, absorb the heat and humidity out of that wheel, and reject it to the atmosphere. So that wheel does nothing but, yes, I'm sorry, what?
You got about a couple minutes.
Oh, okay, all right, I'll speed it up. So effectively, that wheel does nothing but rotate between those air streams, exchanging heat and humidity. It's about 85% effective at rejecting heat, so you don't get the full benefit of the outside air. But when you're using that wheel, guess what you're not using? The compressors. And that's how you're saving lots of energy. So air side economizers, that's effectively what we're looking at here. There's direct and indirect on the air side. That's when you're using air to cool and dehumidify the space. Water side economizers apply to chill water. Effectively, what water side economizers are is instead of using the compressors to reject the heat, if it is cool enough outside, you can use just the outside air to transfer the heat from that fluid to the outside air. The problem with water side economizers, they're usually less effective at transferring the heat. And then in addition to that, they're really cumbersome to initiate. There's a lot of manual steps involved there. And ultimately, what I find is a lot of them just don't get used because of that. All right, looking at air distribution, your ductwork system. So I'm going to tell you just kind of our philosophy at Harvest Integrated, which is we try to get that air as closely coupled to the plant as possible. If we can get that air next to the plant, we can deliver air that the plant wants, at the temperature it wants and at the humidity level it wants. If you don't put that air next to the plant, you got to mix it in the room, which means you got to send it out cool enough that it's going to mix with the heat in the space to give you the set points that you're looking for or what the plant wants. So most air coming out of a system is going to come out at 55 degrees. Your plant's not going to like 55 degrees blowing on it. But if you have the ability to get that air next to the plant and say you can move it up to 65 or 70 degrees, whatever you want there, you're saving energy by doing that. It also provides tighter control of the canopy climate. But you're not always going to be able to do that. So I'm just going to give you another situation here, another philosophy to look at. Again, we're looking at trying to distribute the air properly to the plant. What you're looking at here is a project we did in Canada. Effectively, you're looking at a bunch of air nozzles here that are designed to throw the air at different distances. Okay, so some of these nozzles are designed to hit the plants really close. Some of them are designed to hit mid, and some of them are designed to hit far. Also, what you're looking at here on the bottom is our return air. So the idea is that we've got one fresh single pass loop of air going to the space and back from the space. That will help you save energy if you're able to do that. The alternative is you've got to dump that air into the space at cool enough and dry enough conditions that it mixes with all the heat in the space to give you what you're looking for. And I think I might have done it. So appreciate the time very much. Here's our information if you want to get a hold of us and talk about Harvest Air or anything else. And I really appreciate it, Anthony.
Thank you very much, John. So we're supposed to have Jesse Horton on next. He's overseas right now and he's having some internet issues. So Chris, if you're available right now, we'll have you skip ahead and we'll do security now. And then once Jesse works out his internet, we'll come back to him.
Sounds good to me. Can you see this?
Yep.
Awesome. My name is Chris Eggers. I'm with CC Security Solutions, and I'll jump right into it. My presentation today is just an overview on cannabis security, identifying some of the main vendors that you'll have to engage with as part of your build out, but also some common pitfalls that people typically don't address that lead to, insurance issues, crime issues, safety issues, etc. I recently resigned from law enforcement after 12 years to start this venture. I worked undercover for a significant amount of time around admitted burglars and robbers. And a lot of my knowledge comes from, the actual offenders themselves, learning what they looked for when they targeted businesses and people. I have formal training in crime prevention measures, security audits, et cetera. But really my main sort of secret sauce that I add to my consulting is the ability to look at a space through the eyes of an offender and really identify security deficiencies as they would see them. Permitting is sort of the beginning phase where you should start thinking about security. Not only is it a requirement, but the earlier you start to address some of these issues, the better. One of the components I think that people really miss is a law enforcement liaison component to their security plan. And a security plan is just a written document, typically required as part of the permitting process that addresses the physical hardware in your security system, but also the SOPs or standard operating procedures around how your staff and you use that system. Law enforcement is continuing on a local level to regulate this industry. Out here in California, it's very common to have police agencies sort of identify one officer or group of officers and make a task force to go out there and regulate and make sure that businesses are compliant with respect to security. That's a trend I don't think that's going to stop, and I think something that people need to consider as they start to draft their security plan. When it comes to actually building out the security system, you already have your architecture plans, a lot of the build outs happening, and that's typically where security sort of starts with the camera mapping. A lot of municipalities require you to have a custom and comprehensive camera map and equipment map so that regulators and officials can see exactly what type of equipment you have and the placement of that equipment, because obviously state regulations, local regulations all have an input and say, how things need to be addressed in your business with respect to security. So here in California, keeping it simple with a dispensary example, there's state laws, Bureau of Cannabis Control regulations, city and county regulations, and best practices as well. All things that need to be considered when drafting your security plan, which again is different than the security system. That's the equipment. The security plan is the written document that you're going to need to get through the permitting process. Some of the things that we're going to talk about for physical security is the CCTV, the access control alarm system, remote video monitoring, other physical hardware, safes, etc. My favorite part about consulting with respect to security is this piece right here. It's procedural security. This is not only as a uniformed police officer responding to calls for service and investigating crimes, but also working undercover around admitted burglars and robbers that are targeting, these specific businesses. A lot of the space where risk and liability exists is not in between the gadgets and widgets. And I say that with all due respect because, in security, a camera plays a role, access control plays a role, the alarm does play a role. But I think too many people are reliant just on that alone, and they don't address procedural security, which is your, SOPs and understanding how your staff and you intend to use your business, how your vendors intend to use your business, and how does that relate to security. A lot of issues can be mitigated and avoided if you have addressed procedural security within your business. The next thing that I see that really gets folks in trouble, and I get a lot of calls, unfortunately, after bad things happen, is because there's no quality assurance or quality control written into your security plan. And I get it. People are busy. If you're a cultivator, you want to cultivate. That's wonderful, and that's what you want to focus on. But there is a component to security that needs to be addressed with respect to quality control, and doing some basic checks to make sure that some of the pitfalls are avoided earlier on. And then an overview of a pre-compliance check. And what is that? This is something you can do in-house. This is something you can farm out to somebody. This is something you can maybe even train somebody on your staff, but really having the proper procedures in place and checklists available so that you can make sure that a pre-compliance check is done internally in your organization and that you can address any issues that come up. How does that differ from a physical security audit? A physical security audit is an inspection of a physical space, and it's intended to identify security deficiencies. Lots of different security consultants have different approaches to this. There's a lot of training out there that is, fairly common in my world. But what is not common is the ability to debrief burglars and robbers, on a very intimate level, and learn, really what makes them tick, what motivates them. Why did they choose this building and not that building? Why this business and not that business? And a security audit really can identify a lot of this risk that address in between the main vendors that you're going to engage with, which is CCTV, alarm, and guard. Access control is thrown in there, but addressing that risk that exists in between all of those vendors is super important, and really where I typically see a lot of damage to businesses. This is my personal take on security audits. I look at the physical security, environmental security. We're going to talk about that more, and then procedural security, which we touched on. Physical security is locks, hinges, doors, windows, alarms, CCTV, etc. The biggest point to consider here, and really what I want folks to take away from at least my component or my presentation, is knowing the difference between deterring crime and notifying you about crime. Cameras and alarms, they notify you about crime when it happens, right? You get an alert on your phone, an email, a phone call, because something bad has already happened. Or might be happening. That's a lot different than deterring crime. And so how do we do that? How do we deter crime? What information was I given undercover from admitted burglars and robbers that tell me, this is why I want to avoid one building or one business instead of another? And it's addressing landscaping, lighting, walkways, signage, maintenance, environmental aspects. And a principle is called CPTED, Crime Prevention Through Environmental Design. A lot of municipalities now are starting to go this way as well. They're training their police force, and they're actually having, for example, in Oakland, California, in their rules and regulations, there's CPTED language that is used because they've seen the benefit. And I was undercover for the Oakland Police Department. I did security audits on homes that were burglarized. After they were burglarized, we would do an assessment, and I was trained in CPTED. So we would look at natural access control, natural surveillance, identifying your territory, and maintenance. So natural access control is, understanding how people move and use that space. Natural surveillance is understanding that there are intended users of your space. Let's say a park, a parent with their kid, and then there are unintended users of that space. Let's say I'm walking, nearby with my dog. Everybody has eyes on this space, and addressing natural surveillance, making sure bushes are trimmed back as an example so that people can view your space is super important. Identifying your territory. What that really means is, the processes and procedures, let's say how your guard will use your space, is much different when he's on private property versus when somebody else is on public property. That's just a quick example. And then maintenance, maintaining your property so that it looks cared for and that all these processes are in place. So CPTED, again, just suggests that the design of buildings, landscapes, and outdoor environments can either encourage or discourage crime. And again, I was in a unique position for a period of time where I was around folks who told me, I rob for a living, or I break into buildings for a living. That's how I, either feed my family, support my habit, whatever the case may be. And I obtained a ton of knowledge from these folks. And I remember after taking CPTED training that they were really describing things and CPTED principles to me. They were looking at lighting, they were looking at landscaping, they were looking at signage and walkways, but also and maybe not more importantly, but right up there is procedural security. They understood how people use their space and where those opportunities existed. Really fascinating. And so, procedural security doesn't cost you anything. It can if you hire a consultant, but there's a lot that you can do in-house that can save you a ton of money, that can lead to a lot of cost savings in the future. And then, specific vendors you're going to have to engage with, and what risk and liability do they bring to the table? A lot. A ton. So with respect to security guards specifically, what's the liability that they bring to the table? Well, first of all, a lot of folks don't check to make sure that proper guard cards and insurances are paid for. There's unfortunately a lot of security guard companies that are offering, really, really, really inexpensive guard services. And if you just look at the BSIS website, you might see that they may not be licensed, or that their license is bad or is expired, and therefore likely not paying the proper insurances and stuff. And within cannabis, specifically, the license holder is responsible at the end of the day for their guard. And so having these checks and understanding what their training is, what their capabilities are, are they well versed in de-escalation? Are they going to incur more are you going to incur more liability having them there? Somebody who might be heavy-handed or doesn't understand de-escalation or problem solving, or in some cases, I know that there's guards that just don't understand basic laws that they deal with every day. They don't understand the difference between petty theft and grand theft, and one is a citable offense if caught, and one is an arrestable offense. And so doing your own due diligence can save you a ton of money, a ton of time, and a ton of headache. And so that's a piece that people often miss, that unfortunately comes up as civil litigation is continuing to grow in this industry. People and businesses are being sued for negligent security and premise liability claims. And so it's more important every day to understand what liability your business still has on the table, even if you have a guard camera and alarm. So with respect to staff training, again, this can be done several different ways. It's not super expensive. It can be done, very cheap, to be honest with you, depending on what your business needs. But some things to at least consider and take back and think about are burglary and robbery identification training, how to deal with an active aggressor and emergency response. How do we get back up to running if there's some sort of emergency in our business or in our space? Understanding counter surveillance and what that means. When somebody goes to rob a building, they're typically very disciplined. But when they're casing that space, they typically are a little bit looser and more easily identifiable if you know what to look for. And then, of course, internal theft training, loss prevention plans within the cannabis space is not as popular as I think it should be. And therefore, there's a lot of money walking out of the door and ultimately out of your pocket. So having a good loss prevention training, or at least loss prevention program within your business, is super important as well. And then all these other things lead to, better safety for your employees and your people, your product, your money. And it really just takes a little bit of time to address that. So I know I have money moving, but really I want you to focus on hiring vendors. The biggest thing I can stress is, ultimately they work for you. And understanding their capabilities, what they're able to do for you, what they're not able to do for you, and how they integrate into the functionality of your business is super important. That's my presentation. I due to time, obviously, I went a little quick. I'm available for questions either via email or this chat. I really appreciate the time, and to the other presenters and Anthony for organizing this webinar. Really awesome. Thanks for having me.
Thank you, Chris. I appreciate you giving up your time. Folks are probably wondering, hey, why are you doing or having someone speak to security when it comes to sustainability for facilities? Well, if you don't secure your facility, then what does it really matter if someone takes it away, right? Takes what you're growing or selling or cash or whatever the case may be. So I thought this was pretty important. Unfortunately, Jesse is still having connectivity issues. He's abroad. So I'll try to fill in somewhat. Excuse me, because this is kind of off the cuff, but I do get this question quite a bit when it comes to when folks who want to build a cultivation facility when they engage with engineers and how they should approach the situation. So in most cases, we are going to rely on you guys as the growers to let us know what set points you want in terms of humidity and temperature. Now the reason being is because, one, a lot of times growers seem to believe they have the magic touch, right, when it comes to their plants, and we don't want to mess with that magic. So we ask you guys to tell us what it is. That way, if you don't get the proper yields that you want, we're not responsible for your plants, right? We can do the proper load calculations, but again, we'd like to rely on you guys to let us know, or you get experts like John, who can kind of assist with that. And then two, we get questioned a lot about, well, what type of light should I use? And a lot of times, again, we rely on you and your expertise for growing, because a lot of growers have been around for a really, really long time. One thing I do push, no matter what, is LED, just because over the long haul, it's going to save you money and time. Because if you're dealing with HPS, right, those bulbs have to be replaced. And if your facility is really massive, then guess what? You got somebody who's running around replacing those lights all the time, and that can be pretty cumbersome. Um, so we do have some questions here in the Q&A. So John, we got a couple in here from Marley Paul. What is the variable speed compressor controlled off of?
Let me unmute myself here. Yeah, I'll go ahead and read it if you want, Anthony.
Oh, go ahead. I totally forgot you have
That's all
access
right.
to this. So
what is
ahead.
the variable speed compressor controlled off of? As the compressor slows down, your suction pressure, evap temp will rise, which limits your dehumidification. So when lights go off and you lose the sensible load, but still have the latent load, you keep the compressor speed high to keep dehumidifying. What kind of heat recovery is included to control overcooling? All great questions. So the compressor is controlled off of the either control system that is on board on the piece of equipment. So for example, in harvest air equipment, there's always a packaged controller that is on board, comes from the factory, tested from the factory. And that controller is effectively going to tell the compressor when to stage up and stage down. Additionally, looks like I lost it here, but the question about heat recovery, ultimately, what you want to do is what's called hot gas reheat. So as I mentioned before, you're going to have the refrigerant, let's say on the inside unit. That refrigerant is going to be really cold and designed to absorb the heat out of the air. And then that refrigerant sent outside to effectively be heat rejected, right? So instead of sending that heat outside, instead of sending that refrigerant back outside to lose that heat, you can run that to another coil downstream of your unit or downstream of the evaporator coil and use that to reheat that air. Because you're right, when you dehumidify, you have to get that air down to the dew point. Generally speaking, that dew point is going to be somewhere in the ballpark of 48 to 50 degrees. Obviously, you're not going to want 48 to 50 degrees blown into the space or blown onto the plant. So you then use that hot gas reheat to then reheat that air back up to whatever you're looking for, whether it's 55, 60, 65, 70, whatever it may be. So hot gas reheat is what you used. I guess you'll call that energy recovery. That's what you would use to prevent from overcooling. And your controller on board or from the building management system or from the cultivation management system, whatever you're using, that's what's going to be used to control the variability or the variable speed nature of the compressors. I guess I'll keep going. There's a couple more here on my list. Is there any way to use partially recirc air in lieu of single pass? Yes, the short answer is yes. Quite honestly, if you want 100% outside air into your facility, that's your choice. I have found, and for good reason, that recirculating the air makes sense. Growers know that it makes sense for a lot of reasons, mainly because when it all boils down to it, it gives them more control of the climate in the space. And then it also just mitigates risk. But you do have other things to consider, like room pressurization. So for example, in a flower room, more than likely you're going to want that room to be positive pressure to the rooms around it, or to the corridor around it. What that means is when you open the door to that room, that you're going to feel that air pushing out of that room. The only way you can do that, and you can't do that with 100% recirculated air, the only way you can do that is to introduce a little bit of outside air. So for example, one option we offer is to integrate that pressurization into our units. So we will put a damper in the unit that will allow like 1% of the outside air to come through, treated, filtered, that sort of thing. But just having that 1% will cause enough excess air in the space that it will cause positive pressure. So the long story short is yes, you could absolutely do partially recirculated air. I'm not sure that it would be in lieu of a single pass. Those are really kind of two. The single pass refers to, well, anyway, getting too far down in the weeds there. But hope we answer your question there. And we got one more from Jacob Susser. Apologize if I mispronounced the name. If a specific cultivar requires low dew point, requires low dew point, late flower conditions, what are the options a grower has to balance physical equipment size and operational costs? So this is a very common question. This is definitely one of the situations that is key to design to. So let's see here. What are the options a grower has to balance physical equipment size and operational costs? I'm not sure that your equipment size is going to be able to change. It really goes down to that turn down capability. Having the ability to vary the capacity of your heat rejection and to vary the output of your fans. That's what's going to help you really dial in exactly what you want in that late flower stage. Additionally, what you're going to want is again, more variable capacity is going to be on your heat. So I mentioned the hot gas reheat before. What you'll hear usually is you'll want to look for what's called modulating hot gas reheat. That allows you to adjust the level of heat you have to reheat that air. So long story short, it just kind of goes back to the ability to adjust your capacity in your components in the system in order to match loads in the space. That's the best way to balance those operational costs with the size of the equipment.
You were talking about bringing in outside air. We had a concern with that on a project we did where we were putting on an economizer, but then there's concern about bringing in contaminants, right, from the air and hurting your crop. How do you deal with that?
That's a great question. So generally speaking, we try to not bring in outside air, but again, with that room pressurization, obviously filtration is going to be a big deal. This is actually like a huge topic in HVAC right now within ASHRAE and whatnot. You may have heard some, may not, but bipolar ionization is what we use for indoor air quality control. Bipolar ionization effectively floods the air with ions that are designed to couple with the molecules in the air to thereby neutralize them, not allowing them to get together and form the pests, the pathogens and whatever else it may be. So in my opinion, the bipolar ionization on that outside air, along with filtration or some enhanced filtration, is really the best way to handle that.
Okay, thank you very much. Lynn had another question. Who helps the growers that don't have the support to get a project requirements document or information together ahead of engaging an engineering firm? That's kind of tough. I mean, you can come to us and say, hey, we have a certain amount of canopy space, a certain square footage of office, basically non-cannabis space, and we can give you a loose proposal. But ultimately, you have to start with either a designer, right? Somebody who understands the flow of a facility, or an architect, right? You need something on paper that's showing the building that you plan to lease or buy or build, along with your canopy space. Other than that, I mean, Lynn, I'll show my contact information. If you reach out to me, I do have some resources that I've worked with before. I think we got another question from Jesse. When looking at water rates and transportation, what is the typical watering evaporation rate per plant with a 1 plant per square foot sea of green? Wow.
Is this me? Or is this you, Anthony?
That's definitely going to be
Okay.
you.
All right.
It's definitely not me, John.
I understand. Looking at the watering rates, let me try and make this simple. Generally speaking, when you are sizing equipment, you're going to size for, again, the worst case scenario, the biggest scenario, right? You can effectively assume that that plant's going to transpire about 90% of the water that it's going to uptake. You could also, well, I don't want to say you can assume, we assume that, let's say, for example, you're indoors, that plant's going to transpire that amount, that 75% of what I just said. So 90% of your daily watering rate will be transpired. And the way that it'll be transpired, at least the way we assume it is that 75% of it will be transpired with the lights on and the remaining 25% with the lights off. So effectively, I think that's the best way to answer your question. If it is not, then please reach out. I can definitely go into further detail if you like.
Thank you. Here, I got one more slide to show. All right. Well, first and foremost, I want to thank everybody for attending. I want to thank my panelists. We're going to continue these events, and the next one we have is part 3. This one is going to be on environmental impacts of cannabis and very low cost ways to make your existing facility sustainable while also saving you money on energy consumption. Caitlin Urso, she's an environmental consultant with the state of Colorado. So this is her job. This is all she does all day, every day, is to help facilities become sustainable. I mean, she gave me a project she did where she worked with a beer brewer capturing their excess CO2, bottling it up, and then cultivators were able to use it. So these are the type of out of the box thinking that she has. And my apologies, I thought this presentation had my contact information, but I will show it here. Here is my contact information. If you guys want to reach out to me, feel free to reach out if you have any general questions, if you need us to do some consultation where we go out to look at facilities that you guys are considering buying or leasing, because the last thing you want to do is purchase or lease a building later to find out, well, one, you don't have enough power and maybe it's a year for the power company to get it to you, or you have nowhere to put your condensing units, maybe the roof is old, or you have some property setback lines, right, where you have no place to put them on the sides of your building. So we can evaluate your facility from an MEP perspective to let you know if it's a good idea to buy, or at least give you a decent report so that you can make an educated decision. So again, thanks everyone for attending. I think we have one more question. Jacob said, how does the lighting technology impact your design? Whether the general design differences between an HPS design and an LED design in terms of temperature and humidity? Well, essentially, HPS is going to give you a ton of heat, right? So that heat is going to obviously make you utilize your HVAC system much more heavily. So it really just impacts your air temperature as well as your humidity in space. Whereas if you have LED lights, you're probably going to have a lot more humidity in the space. So you have to be able to offset that. So, and then also with the height of your lights, right? If you have HPS, you can't get as close to bring it down as close to your plants. So if you're doing multi-tiered growing, you're limited by how close you can get it to your plants. I believe that was the last question. So again, thanks everybody. And I will send out more information regarding our future seminars or webinars, I should say.
Thanks for having us, Anthony.
All right, everybody. Bye.
Sure.